Hello, my name is Hussam Ayati. I'm a PhD student and a research and development engineer. I am working on the smart energy management system, and today we will present to you our latest work on latest design of a smart meter based on blockchain. So, in this presentation, we will start by introducing the smart energy management systems and the relationship between these systems and the blockchain. We will talk about the system design of the smart meter and the main requirements. Then we will present the architecture of the blockchain-based smart meters. After designing the smart meter, we have proposed the interactions with the smart energy management system that englobe all the features in the energy management. Then we will see some challenges and the future work. This work presents a full design of the hardware part of a smart power meter that enables blockchain peer-to-peer energy markets within a grid with high security, trust, measurement accuracy. These analyses were tested in a test bench with a low and efficient computational algorithm for hashing. The proposed architecture and design of the smart meter in this paper enables three main features of the smart energy management system, which are the smart metering, digitization, the cybersecurity, and the management of energy markets in a microgrid. In this figure, we can see the different features of the proposed smart energy management, which enables prediction, monitoring, energy markets, optimization, communication, energy management, power scheduling, power shading, load and source scheduling, diagnosis, and smart metering. After analyzing the demand behavior of the grid prosumers, which are the producers and the consumers of energy within the grid, the main challenges with is the smart contract, which has a risk of high energy consumption. Therefore, the use of these algorithms in power systems is a critical challenge that may be solved if the computations would be performed off-chain. Then, the designed smart meter would compute the smart contract and share it with other meters, which will be explained in the design section in this presentation. In other words, the design of the smart meter enables to encrypt transactions and communicate with other meters, creating new blocks in each transaction in a secure way. The use of mini encryption algorithms such as the SHA-256 algorithm is highly secure and can prevent the attackers from falsifying the data. Nowadays, many researchers have proposed a collaborative energy economy considering commercial peer-to-peer sharing and business to consumers, which can resolve the energy sharing and providing to the prosumers a consensus to produce clean energy and to consume energy very wisely. Using the blockchain technology for high secured transactions and data exchange transparency. In this section, a full design of blockchain-based smart meter is proposed, responding to the different challenges and requirements cited in the previous section, including precision, cybersecurity, communication, and interaction with the smart energy management systems. The designed smart meter shall be connected to a residential microgrids. Therefore, the proposed architecture shall be connected to a low AC voltage grid in serial mode. The current and the voltage measured using the ACS 71020 or ACS 37800 or equivalent sensor, which communicate data with an atomic controller using the I2C communication protocol. The energy or the measured energy consumed or produced and is stored in a memory, in addition to the transaction and blocks identifiers, which are computed using the Octo E1 development board. These computed transactions are shared and communicated through log file in order to broadcast the block with all connected smart meters. All components are presented in this synoptic are supplied directly from the grid to a rectifier and charge the internal LiPo battery through a BMS if the energy is available. Otherwise, the internal battery will supply the other components. The proposed architecture is very flexible and easy to maintain, which enables efficient and secure communication with other devices. However, further investigations on the vulnerability of the security and communication between the sensors and the controllers, which requires field testing and ideas to secure this part. The same goes for the communication between the microcontroller and the Octo device. The enclosure of the smart meter has been designed according to the AEC 16950-22. The proposed architecture is very flexible and easy to maintain. The design of the energy meter is based on these standards, which has the same dimension of the other power electrical equipment, in order to make the installation and the fixation easy for users or maintenance electricians. This figure presents the 3D design of the blockchain-based smart meter, which has an antenna for better communication using long-fi helium. In order to test the accuracy of the smart meter, a test bench were designed as shown in this figure. The goal is to test the acquisition of the energy data by changing the intensity of the light bulb of 60 watts from 0 to 100% with steps of 10%. The measurements were parallelly acquired by using an Arduino to test the communication between the ACS and the Octo device. The accuracy of this measurement done using the smart meter in different cycles from 0 to 100% is only 1% of error, which is acceptable in these devices, especially in home appliances or applications. However, many investigations on the accuracy of the hashing algorithm and the visualization software are currently under testing, which requires further studies on the different scenarios and the behavior of the prosumers within the grid. The same goes for the cybersecurity requirements. The novelty of this work is integrating a hardware that will enable the blockchain-based smart meters and the P2P energy market with high security and low and decentralized computation using blockchain design development code. In this part, we will talk about the general architecture, introducing the proposed architecture of the blockchain-based smart meter that will enable the existing smart energy management system to manage energy transactions between prosumers. The measurements of the energy consumptions and production directly with load or the source. The data is transferred to the Octo device or module, which hash the encryption and broadcast in the grid using the helium long phi technology. The hash encryption using the SHA-256 algorithm contains all information which is calculated each hour, resulting the transaction and updating all smart meters, as you can see in this architecture. In this paper, we have developed the hardware parts of the smart meter, and we have designed and test some first prototypes of these smart meters that will enable the peer-to-peer energy markets. We are now currently developing and working on the software and the framework of the P2P energy trading, developing an automated energy trading framework which requires different processing algorithms and bidding algorithms. And after realizing and developing the software parts and the automated energy trading framework, we will test these smart meters and install in a rural or urban case study in order to acquire more data and to further investigate the vulnerabilities of these prototypes. These are the references of this paper. And thank you for your attention.